In the first video of this series, I covered the different concepts of irrigation efficiency. In this video, I'll cover the drivers of irrigation efficiency and how to optimise them. There are many factors that influence and drive an irrigation that we can control and some that we cannot. Your soil type and its characteristics is the main driver of the irrigation and distribution of water in the profile. Your soil's structure, texture and chemistry determines the infiltration characteristics of the soil and hence the advance rate along the furrow. The cracking clays that cotton is generally grown on have a high initial rapid intake of water. The infiltration rate then decreases as the cracks fill and the soil begins to swell, closing up the pore spaces. This characteristics of a slowing infiltration rate enables high application efficiency as deep drainage losses are minimised at the head end of the field whilst the rest of the field is irrigated. The performance of a surface irrigation event is also influenced by a number of design and management factors which, unlike soils, we have a greater control over. The main factors that an irrigator or a manager can control is the inflow rate through the siphon, time to cut off, field length and application depth. The inflow rate affects the advance rate down the furrow. Generally, a faster flow rate is more desirable if recycling tailwater occurs. A higher inflow rate can be achieved by providing more head in the head ditch, using siphons with larger internal diameters, or using more siphons in the furrow. Optimising the time to cut off is also important as cutting off too early will result in underwatering, poor distribution uniformity and crop stress, whilst cutting off too late will result in excessive deep drainage, tailwater, low application efficiency and yield penalties from waterlogging. Field length may also be optimised, but obviously that may not be practical. Field length influences the efficiency of an irrigation, as a longer field length means irrigation water has to travel further down the furrow, therefore reducing the advance rate. It can also mean water infiltrates for a longer period of time at the head ditch end, meaning more water could be lost to deep drainage. However, if flow rate and cut-off time are optimised for the length and soil type, high efficiencies can be achieved. The last factor we can optimise is the application depth or deficit. In certain scenarios, it may be possible to reduce the deficit, which may allow for reduced deep drainage losses and increased application efficiency. Irrigating to a smaller deficit will allow for a higher flow rate, therefore advance rate, which may be useful in soils with large cracks. Reducing the deficit may also enable us to capture more rainfall, but also may result in more frequent irrigations. Caution should also be taken to ensure the crop is not underwatered too much and stressed. An irrigation consultant should be engaged to optimise the inflow rate, cut-off time and application depth or deficit to suit your soil's specific characteristics. By optimising these parameters, we can improve application efficiency, distribution uniformity and save water. There are also other methods to improve irrigation efficiency. These include maintaining levels in the head ditch to ensure constant flow rate to the field. If the water level drops, so too will the flow rate and therefore efficiency. Using the same siphon size is also important as the internal diameter influences the flow rate. Knowing the exact siphon size and the type is important as metric and imperial sizes specify diameter differently. Finally, the irrigation duration of point rows should be managed to ensure they aren't over-irrigated, causing waterlogging. Thanks for watching our videos on irrigation efficiency. If you'd like to learn more about this topic, head to our CottonInfo website or alternatively, talk to your local irrigation and water expert.